sine, cos, cosecant, secant function. After interval 2 pi, the value will repeat. An equation involving trigonometric functions with the variable is nothing but your trigonometric equation. When we restrict the solution only for one interval, that is from 0 to 2 pi, from 0 degree to 2 pi, if we restrict the solution, we call those solutions as principal solution. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So I am in the last session of the chapter Trigonometry. So in this session, we'll be dealing with trigonometric equation. So let's see what is this trigonometric equation and how we are going to solve this trigonometric equation in terms of angle. Whatever the solution of these equation, they are all be in terms of angles only. So what do you mean by the trigonometric equation? As in earlier classes, you have learnt many polynomial equations, quadratic equations, linear equation. In the same way, here the equation involves trigonometric functions with the variable. Therefore, an equation involving trigonometric functions with the variable is nothing but your trigonometric equation. Here I have taken an example. In general case, it is like 2x minus 1 is equal to 0. This is a simple algebraic function, but here you have a trigonometric function along with the variables. Therefore, we call it as a trigonometric equation. So 2 sin x minus 1 is equal to 0, trigonometric function. Sin x minus cos x is equal to 0. 2 tan square x minus tan x plus 1 is equal to 0. So these equations involving trigonometric function with the variable are nothing but trigonometric equations. Now, here are some important points you should know when you are solving the trigonometric equation. We know that the values of sine and cos repeat of an interval of 2 pi. That is, after one complete revolution from 0 to 360 degree, the value of cos function as well as sine function repeats for 2 pi. And this is same for cosecant and secant function. They repeat after an interval of 2 pi. But the tan function repeats after pi only. That is, if you have a circle like this with 4 quadrants from 0 to pi, the value of tan from 0 to pi repeats from pi to 2 pi. Therefore, tan x repeat after an interval pi, that is the values repeats. Whatever the values you will get from 0 to pi for the tan function, the same value will repeat from pi to 2 pi. Therefore, tan x repeats after an interval pi, and this is same for cot x also. So therefore, sine, cos, cosecant, secant function after interval 2 pi, the value will repeat. For tan and cot, the intervals repeat after pi. Therefore, your value will be same after an interval of pi. Next, coming to the solution. As we solve or as we find the roots of a quadratic equation or roots of a linear equation, solution to linear or quadratic equation, they are all one and the same. Similarly, we have a solutions for trigonometric equation. But for a trigonometric equation, you have infinitely many solution. Why infinitely many solution? Because after one complete interval, the value will repeat after you add or subtract the angle. Because the value of sine 0 is 0, sine 2 pi is also 0, sine 4 pi is also 0. Similarly, cos pi by 2, cos 3 pi by 2, cos 5 pi by 2, all value is 0. So, for many angles, the values is same. So, therefore, the solutions of trigonometric equations are infinite. But when we restrict the solution only for one interval, that is from 0 to 2 pi, from 0 degree to 2 pi, if we restrict the solution, we call those solutions as principal solution. Otherwise, for n values, n may be infinite or n may be certain number of values also, they are called as general solution. the solution of trigonometric equation is called principal solution if the solution lies between the interval 0 to 2 pi. If we take instead of 0 to 2 pi, then the expression involving integer n is nothing but your general solution. For example, if I say your solution is pi by 2, the solution pi by 2 lies between 0 to 2 pi, so therefore it is called as principal solution. If I take it as n pi by 2, I can put integral values for n, that is integer values. So if I put n is equal to 1, minus 1, any number I can replace. So you will be having n number of solution. As I said, they have infinite number of solution. And all those solutions generally will write it an expression form, that is called as general solution. So one more concept, whenever a function is given with its value, we are going to find for what values the function is given that value. For example, if I write tan x is equal to 1, I should find for what values of x the values will be 1. So we know that tan pi by 4 is 1. So pi by 4 is 1. Similarly, I said, so tan pi by 4 is 1. Also, it may have the values of different angles whose value is equal to 1. How to calculate? What is the function given here? Tan x. The value is plus. In which quadrant the tan is positive? So if you represent it in a quadrant, so we know that ASTC rule. So tan is positive in third quadrant and first quadrant. So therefore, if you take the angle as x, that is pi by 4 in the first quadrant, if it lies in the third quadrant, you should take it as pi plus pi by 4. So which is nothing but 5 pi by 4. So therefore, it can also, so therefore the tan value of 5 pi by 4 is also 1. So you can have 5 pi by 4 as a solution. Similarly, after one complete revolution, again 360. 360 plus pi by 4, that is 2 pi plus pi by 4, which is nothing but your 7 pi by 4. So similarly, after one complete revolution, so 360 plus pi by 4, again first and third quadrant. So for many angles, tan function may have the values 1. So therefore, the value of x may differ, or it may have infinite number of solution. But when we restrict it from only 0 to 2 pi, x can take the values only to 2 pi, means the only solutions of tan x are pi by 4 and 5 pi by 4, because it is between 0 to 360 degree. Those solutions are called as principal solution. And if we express this in terms of general solution in the form of n, they are called as general solutions. So therefore, to find the principal angle in different quadrants, first you should see what is the function given, whether it is positive or negative, and you should see if it is in the first quadrant, the solution is same as, for example, for pi by 4 you will get 1, so answer is pi by 4. If the solution lies in the second quadrant, you should take an answer as pi minus a. For example, if it lies in the second quadrant, you should take it as pi minus pi by 4. Similarly, pi plus a for third quadrant, 2 pi minus a for the fourth quadrant. So here we are, find the principal solution for the following equation. Sin x is equal to root 3 by 2. First, check whether it is positive or negative. So here clearly we can see the value of sin is positive. So let us write the quadrants now. So where is sin function positive? In the first quadrant it is positive. Also in the second quadrant it is positive. So if it is in the first quadrant, you should take the same angle. If it is in the second quadrant, you should take it as pi minus a. So therefore, here let us find what is x now. For what values of x? Sin function is root 3 by 2. So we know that sin 60 degree, that is pi by 3, is root 3 by 2. So for sin pi by 3, the value is root 3 by 2. Also given sin is positive. So if it is positive, so therefore the solution lies in the solution lies in first and second quadrant. First and second quadrant. So how we will take the solution in the first quadrant? As x itself. So therefore, this implies the solutions are, so in the first quadrant, we take the value of x as itself, that is pi by 3. But in the second quadrant, you can see you take the solution as pi minus a. So therefore, it is pi minus pi by 3. So therefore, the solutions are pi by 3 and 2 pi by 3. So 2 pi by 3 is nothing but your 120. So therefore, the value of 60 degree as well as 120 degree is same, that is root 3 by 2. And we are calculating only from 0 to 360 degree. Therefore, they are called as principal solutions. Next we have cot x is equal to minus root 3. So here, for what values of cot x, you will get it as minus root 3. Leave minus, just see for what values of cot x you will get root 3. So you will get cot pi by 3 as root 3. But cot is negative here. So just find wherever the cot is negative. So we know in the first quadrant all angles are positive. So cot is not negative. In the second quadrant, cot is negative. Third quadrant, it is positive. Fourth quadrant, it is negative. So therefore, the principal solution of this lies in second quadrant and the fourth quadrant. So therefore, the solution lies in second and fourth quadrant. So, how we will take the solution in the second quadrant? As pi minus a, and fourth quadrant we take it as 2 pi minus a. So therefore, this implies the solutions or the principal solutions are, in the second quadrant it is in the form of pi minus a, that is pi minus pi by 3, and fourth quadrant it is 2 pi minus a, so therefore 2 pi minus pi by 3. So therefore, the principal solution are so pi minus pi by 3 means 2 pi by 3, and here it is 6 pi minus 5, 5 pi by 3. So for 2 pi by 3 and 5 pi by 3, the value of cot is negative, that is minus root 3. So I'll explain. Here they have given negative. Just find for what values of cot function you will get root 3. Then observe the sign in which quadrant it lies. So based on the quadrants, you choose your solution. Since it lies in the second quadrant, you take it as pi minus pi by 3. Fourth quadrant, 2 pi minus pi by 3. Solve it, you will get the principal solution. Second question, cot x is equal to minus root 3. Just first see for what values of x you will get root 3. We know that cot pi by 6 is equal to root 3. But here cot is negative. But given cot is negative. Correct. So negative means in which quadrant cot is negative? First quadrant all are positive. Second quadrant sine and cosecant. All others are negative. So cot is negative here. Third quadrant tan cot positive. So no need. And in the fourth quadrant cot is negative. So therefore the solution lies in the second quadrant and fourth quadrant. If we have the solution in the second quadrant, we take it as pi minus a. And in the fourth quadrant, we take it as 2 pi minus a. So if my a is pi by 6. So therefore, the solution lies in second and fourth quadrant. This implies the principal solutions are what are the solution? One is pi minus a, another one is 2 pi minus a. According to this, it is pi minus pi by 6 and 2 pi minus pi by 6. So therefore, the principal solution are 5 pi by 6 and 2 pi into 6 is 12, 12 pi minus pi, 11 pi by 6. So therefore, for 5 pi by 6 and for 11 pi by 6, the value of chord function is minus root 3 between the interval 0 to 2 pi. Next one, here we have, first let us solve it. So this can be written as root 2 cos x is equal to 1, cos x is equal to 1 by root 2. For what values of cos function it is 1 by root 2? Cos pi by 4 is 1 by root 2. And we have seen the given function is positive. So, we'll write the quadrant. Cos is positive in the first and fourth quadrant. If it is in the first quadrant, we take it as A. If it is in the fourth quadrant, we take it as 2 pi minus A. So, therefore, here the principal solution, we can write directly the principal solutions are, one is pi by 4 and another one is 2 pi minus pi by 4. So, this implies the solutions are pi by 4 and 2 pi minus pi by 4 means 8 pi minus pi, 7 pi by 4. So, these are the two solutions between 0 to 2 pi. Next, we come across the general solutions of the trigonometric equation. So, here we have given the general solution, just learn it. Proof is not necessary. So, if you have an equation as sin x is equal to sin y form, then generally you can express the solution of sine function as n pi plus minus 1 whole power n y, where you can take only the integral values, only the integer values are allowed here. Similarly, if you find any functions of cos x, general solution for cos x function is 2n pi plus or minus y. N can take any values of integer again. If you come across a tan function, then the solution can be taken as n pi plus y. So, where n belongs to z here again. So, you have only solutions for sine, cos and tan. Why not for cosecant, secant and cot? Since they are reciprocals, if you have any functions in the cosecant form, you can convert it into sine form. Then you can write the same solution. Similarly, for secant, convert to cos and sine, write the same solution. Cot, if you get, convert it into tan, write the solution in the form of x is equal to n pi plus y. Let us solve these equations. So, general solutions or principal solutions. Now, how to find the general solution of a trigonometric equation? Let us see now. Find the general solution for each of the following equation. The very first question is given as cos 4x is equal to cos 2x. Now, let me write this equation as cos 4x minus cos 2x is equal to 0. This looks like a transformation formula of cos x minus cos y. What is cos x minus cos y? Minus 2 sin x plus y by 2, that is 4x plus 2x by 2, and sin x minus y by 2, 4x minus 2x divided by 2 is equal to 0. So, here we can leave this because minus 2 is not equal to 0, I can equate this to 0. So, when you cancel this, sin 4x 2x is 6x, 6x by 2 is sin 3x into sin 2x by 2, x is equal to 0. So, this implies what? Sin 3x is equal to 0 and sin x is equal to 0. Now, for what values the function sin becomes 0? That is, sin 3x is equal to sin n pi. So, for any values of n pi, the sin function is 0. So, if we equate, we will get 3x is equal to n pi or x is equal to n pi by 3. So, this is the general solution, and this side sin x is equal to sin any pi, n pi we can take. So, x is equal to n pi is the solution. So, where n belongs to set. So, Just solve the formula. So you will get how you are going to factorize. For example, if you have any trigonometric equation, x plus 6x plus 5 is equal to 0, you would get the factors as x plus 2, x plus 3 is equal to 0. And you would have taken it as x plus 2 is equal to 0, x plus 3 is equal to 0. So therefore, x is equal to minus 2, x is equal to minus 3. In the similar way, here you got two factors, equate them to 0. For what values the sine function becomes 0? Sine any pi is 0. So therefore, we will take it as n pi. We have same trigonometric functions on both sides. Just equate the variables. So you will get x is equal to n pi by 3. Here you will get x is equal to n pi. Since the term n is present here, for n we can take any values of integer. Therefore, this is called as general solution. Whereas in previous cases, we would have get as pi by 4, 2 pi by 4, pi by 6, 5 pi by 6. So in terms of angle only we used to get. But here we have pi by 3, but in terms of n, so therefore we can put many values for n. That means we can find infinite number of solutions. Therefore, this is called as general solution. Next we have cos 3x plus cos x minus cos x is equal to 0. So same method, apply transformation formula. So let me solve this. So cos x plus cos y, 2 cos x plus y by 2, 4x by 2 is 2x. Cos x minus y, that is 3x minus x is 2x, 2x by 2 is x, minus cos 2x is equal to 0. Take the common factor, you will get cos 2x into 2 cos x minus 1 is equal to 0. Equate them, one is this, cos 2x is equal to 0. Another one is 2 cos x minus 1 is equal to 0. Now here, for what values of cos function, the equation becomes 0. That is, cos 2x is equal to cos 2n plus 1 pi by 2. For all multiples of pi by 2, I already said in previous sessions that odd multiples of pi by 2 of cos function will become 0. So when I equate this, I'll get 2x is equal to 2n plus 1 pi by 2, or x is equal to 2n plus 1 pi by 4. So this is the solution of the first equation. Now coming to the second equation, here we have cos x is equal to 1, cos x is equal to 1 by 2. When is cos function is 1 by 2, that is cos 60 degree, that is pi by 3. So therefore here you can take x is equal to pi by 3. But here you cannot just write it as pi by 3. Whatever the general solution you get, you should write it in an n form. How we will represent this? When you have an equation of cos function, if you get the value as y, just add 2n plus pi plus or minus y. So therefore here the solution is x is equal to 2n pi plus or minus pi by 3, where n belongs to z. So this is the solution. Here we already have the equation of n, so no need to add 2n pi. So when you get only the angle, just add 2n pi to the given angle, then it will become the general solution. Otherwise, it is only the principal solution. Next, we have one more function here, secant square 2x is equal to 1 minus tan 2x. We know the trigonometric identity, that is 1 plus tan square x is equal to secant square x. So just apply here, but here you have 2x, so apply it as 1 plus tan square 2x is equal to 1 minus tan 2x. Now 1 cancels on both sides. You have tan square 2x. Shift this tan 2x here, it becomes plus tan 2x is equal to 0. Now tan 2x common factor, so plus 1 is equal to 0. So now I can equate this as tan 2x is equal to 0. Similarly, tan 2x plus 1 is equal to 0. So let me solve this. For what values the tan function becomes 0? So therefore, this is for n pi. For any pi, the value of tan is 0. So therefore, I can write it as 2x is equal to n pi, or x is equal to n pi by 2. where n belongs to z. So this is the solution of the first equation. Now here we have tan 2x is equal to minus 1. So now here we have negative. For what values the tan function is negative? First, this can be taken as minus tan pi by 4. Or you can also write this as tan 2x is equal to tan pi minus pi by 4. Why pi minus pi by 4? Because in the second quadrant tan is negative. So you can write it as tan pi minus pi by 4. Because tan pi minus pi by 4 is nothing but minus tan pi by 4. Why? Because in the second quadrant, the value of tan is negative. Here we get 2x is equal to 3 pi by 4. But I cannot write the solution as 3 pi by 4. For tan function, I should write in the form of n pi plus y. Therefore, here I'll write it as 2x is equal to n pi plus 3 pi by 4. If you want x, then it is n pi by 2 plus 3 pi by 8, where n belongs to z. So this is the one more solution of the given equation. First solution is x is equal to n pi by 2. Second solution is n pi by 2 plus 3 pi by 8. Remember, when you get only the values, add n pi for tan, 2n pi for cos, and minus 1 whole power n for sin. Next, we have an equation here, sin 2x minus sin 4x plus sin x. First, rearrange this. Sin 2x plus sin 6x minus sin 4x is equal to 0. Find what is sin x plus sin y. Sin x plus sin y is 2 sin x plus y by 2. 2x plus 6x, 8x by 2, which is 4x. Next, cos 2x minus 6x is minus 4x by 2 minus 2x. Minus sin 4x is equal to 0. So you have 2 sin 4x. What is cos of negative? Positive. So cos 2x minus sin 4x is equal to 0. Now you have sin 4x as common. Take it outside. You have 2 cos 2x minus 1 is equal to 0. One function is sin 4x is equal to 0. Another function is 2 cos 2x minus 1 is equal to 0. Let me solve the first one. This is nothing but sin any pi. So therefore I can write 4x is equal to n pi, or x is equal to n pi by 4, where n belongs to an integer value. So this is the solution of first equation. Second equation, 2 cos 2x is equal to 1. Cos 2x is equal to 1 by 2. That is nothing but cos pi by 3. So now you have 2x is equal to pi by 3. So for cos function, you should add 2n pi plus or minus. So 2x is equal to 2n pi plus or minus pi by 3, or x is equal to divided by 2. So this is n pi plus or minus pi by 6. So this is the solution of the second equation in terms of n, where n belongs to z. Next, we have 2 cos square x plus 3 sin x is equal to 0. We know that cos square x can be written as 1 minus sin square x plus 3 sin x is equal to 0. So this is 2 minus 2 sin square x plus 3 sin x is equal to 0. Or you can write this as 2 sin square x, when you multiply minus 3 sin x minus 2 is equal to 0. So as you have done splitting the middle term in general equations of algebraic terms, we apply the same method. This can be written as 2 sin square x minus 4 sin x plus sin x minus 2 is equal to 0. Take 2 sin x common. You will get sin x minus 2 plus 1 common, sin x minus 2 is equal to 0. So here you have 2 sin x plus 1 into sin x minus 2 is equal to 0. So now 2 sin x plus 1 is equal to 0. Sin x minus 2 is equal to 0. Now let me solve this equation. This is 2 sin x is equal to minus 1 or sin x is equal to minus 1 by 2. So that is nothing but minus of sine pi by 6. I'll write here. Now pi by 6 I can write it as pi minus pi by 6. So therefore sin x is equal to, so here we have minus sine pi by 6. I cannot take pi minus pi by 6 because in the second quadrant it is positive. So I'll take the third quadrant. I'll write this in the third quadrant. We'll write it as pi plus a. So therefore pi plus pi minus 6. Now therefore x is equal to pi plus pi by 6, which is nothing but 7 pi by 6. But you cannot write only 7 pi by 6. Since we are doing for the sine function, the general solution is expressed as x is equal to n pi plus minus 1 whole power n into given angle, that is 7 pi by 6. Here n belongs to z. So this is the solution of the given equation. 2 sin x plus 1 is equal to 0 in terms of general solution. Now here we are left with sin x minus 2. This implies sin x is equal to 2. It is not possible. I'll write it is not possible. So it can never happen. Why this is not possible? Because the maximum value of sine function is 1. The minimum value of sine function is minus 1. We have learned the domain and range, also the graph. So how was the sine function? It was like this. Correct. The maximum value is 1. The minimum value is minus 1. The range of the sine function lies between minus 1 to plus 1. So sin x is equal to 2 cannot happen. So therefore there is no solution, or we can say it is not possible. Yes, this completes our trigonometric chapters. All the trigonometric functions in terms of unit circle, that is we have studied in terms of radians, their properties, functions, compound angles, sum and difference, multiple angles, transformation formulas, and application of all those identities and formulas in trigonometric problems. At last, we come across trigonometric equation and how to solve those trigonometric equation in two types. One is principal solution and another one is general solution. Principal solution is the solution where we will restrict the solution from 0 to 360 degree. So you may get only 1 or 2 values. But general solution means since trigonometric equation values will repeat after each interval, it may have infinite number of solution. So therefore, there all the solution is expressed in terms of general equation, which is called as a general solution. This is all about your trigonometric functions. Hope you enjoyed all the sessions of trigonometry. We'll meet you in the next session with a new chapter. Until then, keep watching, keep learning and keep exploring. Thank you.